So I'm gonna, some of them I told you I'd have more information for you. Some of them I'm just gonna touch on again to remind you about more popular ones, etc. So go through. ATPC is typically used on a short range path. Okay, if you're running max power, ATPC doesn't do anything for you. It doesn't buy you any more transmit power. If it rains, it can't turn the power up any higher than it's already turned up. Okay? So typically short paths going across the street with your 4-foot dishes because you have them sitting in the warehouse or whatever, and you're overloading the far side. Okay? Prevent receiver overload. We talked about how the Europeans use this to reduce interference to other transmitter or other receivers. Don't use ATPC when you're running the max power, unless you're using it in conjunction with the ACM. Okay? Remember, this is how the ACM works. It shifts down through the modulations as rain fade comes through, then it shifts back up, completely hitless as it goes. ACM does use a very small amount of your bandwidth, and it does change your receive sensitivity, a very small amount. Okay? So just know that you know, in technicality, you are giving something up to have it. You probably will never notice the difference. Most of you probably want ACM on. However, I know there's some people out there that go, hey, this link was engineered for 5 nines reliability at COM 256. We really don't need ACM for those 3 minutes. Just let it drop. Okay? All you got to do is turn it on. It's got to be turned on both sides. If you are going to use it, your license should specify that you're using it. Okay. One thing I did not mention really in detail yesterday, it was kind of up on the slide, but I didn't talk about it. When you look at 6 gig or 11 gig, there's requirements for minimum throughput, efficiency requirements there. Effectively, you've got to run 64 QAM, I think, or higher at 6 gig, and it's 16 QAM for the most part, but it's 64 QAM on the 80 meg channel in 11 gig. Now, if you use ACM, you are allowed to go below those modulations as long as the link was engineered for 99.95% reliability at or above that threshold. Okay. So you could, on your 11 gig link, even though you have to be running it at 64 QAM, you know, by law, if you've got 4 nines reliability at 256, it can shift down to QPSK when it needs to. That's legal. But again, you do need to license it for ACM. Now, you can do the adaptive power control, which combines the ATPC with the ACM. It's very simple. You just put in the max power that you're licensed for here. And by license, I mean what the FCC has allowed you. Okay? Again, you need to be licensed for ACM and then the additional power there. Make sure if you use this that this target RSSI is achievable. Okay? We set the target RSSI to match what your path calc says. If the best you could do was 10 dB off of that, and you've given up, and you don't want to call me and complain to me because you know I'm going to tell you what you need to do, change your target RSSI for me. Okay? Make this match what you're actually getting, because you don't want your syslog to be full every second of a send me more power log. Then you really will have nothing useful. Okay, class of service we already talked about, I think, pretty clear. You do have 4 queues on the Apex Plus. You have 8 queues on the Gigaplus. By default, the queues are strict. So queue 3 is all empty before queue 2, before queue 1, etc. Okay. Again, by default, you don't have to do anything with this necessarily. We map the VLAN priority service into the class of service for you already. We do not, we ignore the DSCP by default. If you want the DSCP to work, you've got to map it into the priority. All right, egress rate has changed a little bit since I made these slides, but they're still relevant. Egress rate is used for fine-tuning the quality of service strictness. Okay. Like we were talking about before with quality of service, you want to do this as early in the process as you can, but it only works if the switch or the router knows how much bandwidth is available. Okay? Inside of the radio, we've got a switch, even if you're only using one port, because it feeds the IBM, and then that goes into the modem. Quality of service happens at the switch. So we've got to tell the switch how much speed the modem's capable of handling. If you remember back to the slide from the Expo a few minutes ago, the 64-byte packets only got 760 megabits, while the 1518 got 981 or whatever. Well, that's where the problem comes in. If I set the quality of service to 981, and all I'm sending are 64-byte packets, quality of service isn't worth anything, because I'm telling you that I have 200 megabits more than I have. Doesn't do any good. Okay. Generally, you got a mix of traffic. It all works out in the end, supposedly. Okay. So we set what the modem's capable of, and then we add or subtract a percentage to it. Okay. So if the modem's capable of 300 megabits, and you put 10% in here, we're going to tell the switch that you've got 310 megabits. Likewise, if the modem's capable of 300 megabits and you set this to negative 10, we're going to tell the switch you have 290 megabits to work with. Okay? So the smaller the number, or the more negative the number in that case, the tighter quality of service you're going to have, but it is going to come at some expense of throughput. The wider the number, go to the extreme, go to 100% above it. Okay, 90% above, that's all we allow. You're going to have the maximum throughput you could get, but the quality of service isn't going to work at all. Okay. Now, what does this really mean for you? Well, here you go. Large packets, it's really not going to change anything. Okay, you're going to get the same amount regardless. Small packets, though, you will see a pretty dramatic difference between those settings. So typically, you're going to set it about 10%. Okay, it's a good trade-off between quality of service and throughput. If you see that you need a little bit better quality of service, set it a little lower. Set it to 5%. Set it to 0. Set it to -5. Whatever you need to do. But once you start going negative, you are going to start impacting these large packets as well. Okay. So there's the throughput numbers. This is all in the support portal. If you want to see the actual numbers too, just search for egress. Bursting, so how many packets or frames per burst? Okay, again, really no difference up here at the large packet sizes. But for the small guys, you're talking the difference of 420 versus 470 frames per burst. Good news, latency doesn't matter what you have it set. Okay. All right. Who was thoroughly confused by in-band management?